Hi there, everybody. This is Mr. Hopper joining you yet again from the Anatomy2 lab. The plan for today was to come wandering in here and show you guys some amazing information on the lymphatic system in replacement for physically being here and being able to look at microscope slides and see models of lymphatic structures. The plan was to show them to you on video so that you could have a better grasp of how the lymphatic system works, because frankly, the lymphatic system doesn't get nearly enough love. Okay, it's very important. Even your textbook, the opening paragraph of it starts out with something like, "They can't all be stars." It's a terrible way to approach this situation. Your lymphatic system is very important and very meaningful in its role in the body. And that is, as you all know at this stage, that as your heart pumps blood and blood circulates through your capillary beds, fluid gets left behind in your capillary beds, and that excess fluid is taken up by your lymphatic system. Very, very important for us, okay? Being able to take up that excess tissue fluid keeps your blood in appropriate osmolarity in terms of the amount of fluid there and keeps you alive. Further, as lymph is cycling through your lymphatic system, all right, going through your lymphatic vessels up to your lymph nodes and moving through the lymph nodes back to, in most of us, the cisterna chyle, and then back up into your big ducts, dumping into your venous system. As this is all happening, it's being constantly tested by your immune system to keep you healthy. So your immune system is working in and with your lymphatic system on a moment-to-moment basis to keep you healthy. So this system is very important. But I look around the room, I search through many trays of slides, and there's just nothing to show you, really. That breaks my heart. So I'll show you what I have, which is a little, and then unfortunately I'm going to be pointing at a computer screen to show you the rest, which is not the way I'd like to do this lab, but it's what I have. Okay, so we're going to do our best with what we got. We're going to keep it simple and give you the bare essence of what you need to make it through this next exam. So let's go. So here we have the PDF on the lymphatic system. So I have uploaded this for you. It is available at the moment. I'm sure that some of you have been somewhat working on it, and that is fantastic. This is the thinnest of the PDFs that we have, and it does have some decent information on there. So it goes through and it shows you some brief information on the lymphatic system and kind of walks you through some of the major parts and pieces here, which is not bad. I am going to try to go into a little bit more detail so that you can kind of see things without, picking through what I would consider not particularly great images. Like, what are these little things down here? Well, what those are lymph nodes, and I'm going to be showing you those on a screen so you can see it blown up in good form, if you will. And on the back of this, they kind of go through and they line out the major parts of the lymphatic system. They mention your appendix here, which is very important for sort of keeping track of bacteria in your large intestine. You've got lymph node clusters, being cervical in the neck, inguinal around where your legs connect, thoracic in the thoracic cavity, and then axillary where the arms connect. All right, so for instance, down here, one of the very few things in this whole lab that's got a lymphatic basis, you can see some lymphatic vessels coming up and connecting to lymphatic nodes. Again, what I want you to notice is these efferent nodes are connecting in. There's 3 of those, and then 1 afferent node coming out. So there's lots coming in, very few coming out by comparison. And the reason for that is we want, in these lymph nodes, we want the lymph to slow down dramatically so that anything that's in there can be checked on by your immune cells. Think about your B cells, particularly looking for particular antigens, and then your macrophages being able to sense that and pick those up and destroy them, and then present those antigens to your T cells. Okay, so what's happening here is, in these lymphatic nodes, is we're going to have fluid flowing up. Let's say you get an infection on your leg here. Okay, you get an infection on the leg. What'll happen is fluid from that, carrying whatever bacteria or what have you are there, going to move up through these lymphatic vessels. Okay, they're going to make their way into a lymph node to those germinal centers that you'd find inside of that lymph node. And all of your lymphatic tissue has these germinal centers. You're going to see them. These are going to be areas where you have B cells that are just cranking, man. They are doing their thing, B and B cells, looking for antigens. And when they find one of these antigens, they will mark it. That will then flow into a core of that lymph node, the cortex itself, a core of the cortex. We're going to find a bunch of macrophages. The macrophages will pick up these marked bacteria and attack and destroy them. And then they will present the antigens from those formerly marked bacteria to T cells. So you got to imagine your T cells, again, would be made in the thymus gland, or they're going to be made in your bone marrow, but it'd be hanging out in your thymus gland, which would be kind of in here. This is your thyroid, not your thymus. The thymus would be down in here. It is not present on this particular model. This must be an adult, like an older adult, because the older you are, the less thymus you have, if you guys can remember that. So when you're a very young child, you have lots of thymus, and when you are older, it sort of slowly goes away. All right, regardless. So the thymus gland would be making these T cells, and the T cells are constantly cycling through the body, doing what we call immune surveillance. They're just cruising through the body at all times, and they will be going through these lymph nodes in one side and out the other. T cells are constantly moving, and as those T cells travel through, the macrophages there can present them antigens that have been found, and then these T cells will cruise around the body looking for more antigens that look like that. Okay, so yeah. That's sort of how the lymphatic system works in very brief detail. So with that in mind, I would like to show you some more things. So we've talked a little bit about these lymph nodes. You have a grasp of where these are. Again, let's just take a quick look-see. So cervical nodes would be in the neck. Inguinal nodes are going to be down here. Those are inguinal nodes. Thoracic nodes would be all throughout the thoracic cavity. I mean, let's be honest, you got lymph nodes everywhere. And then axillary nodes would be around where the armpits connect, okay, deep in there. So like if I could feel a bump here underneath my arm, that would be an axillary lymph node. Now, what else do we have? We've got our right lymphatic duct, we've got our cisterna chi. Full disclosure, I really fight myself on this because I learned this is the cisterna chi. But on the internet and in your text, when I look up the spelling and the way it's enunciated, it's supposed to be chyli, okay? Cisterna chyli. I struggle. I'm just telling you my bias. This is a big vessel, big lymphatic vessel, if you will, deep storage vessel down inside of the thoracic cavity. And I'll be showing you that soon. It'll be kind of right underneath my finger, but deep down in the body. What else do we have? We got the spleen here. We got our tonsils. So your spleen would be there. Tonsils are all in here, and I'll be showing you some images of that here in a little while. And look what I have discovered. So what we have here is a nice image, if you will, of the head. Nice multi-dimensional image, if you will, all right? And in this, we can pull the tonsils, which is great. So the way we're going to do this is as follows. We have the pharynx back here, so the pharyngeal tonsil would be here. You have a lingual tonsil attached to the tongue down here. Lower down here we have the palatine tonsil, just below their soft palate in the grand scheme, okay, palatine tonsil. And then the one that's left over, right, if I pull my sheet out here and show it to you, is the tubal tonsil, all right, tubal tonsil. I've never really heard about this a whole lot. The rest of these are very common. They're in all the diagrams, but tubal I'd not heard much about. Apparently, the opening to your pharyngotympanic tube that drains the ear has a small amount of lymphatic tissue there that's considered a tubal tonsil. So what we're doing here is we're trying to block off all avenues of attack so that if bacteria or what have you are coming in from any direction, we have means of picking up their presence in order to alert your immune system. Okay, we have pharyngeal, tubal, lingual, palatine. Okay, palatine. And that's got it. And then general histology, we're going to look at lymph nodes, which is one of the few slides that I actually have. A spleen, Peyer's patches. These are going to be in the ileum of the small intestine, tonsils, and the thymus gland, which I don't have anything for. So we're going to not worry too much about the thymus gland at this stage in our lives, but we will look at the rest of these. Now, what else I was going to show you? I believe, well, let's see. All right, I remembered what I was going to show you. So if you think back to when we did these blood vessels, I mentioned these two little openings that are present on this model. And the reason I show these is because this is the areas where your lymphatic system dumps lymph back into your bloodstream to maintain your blood's general osmolarity. This is your right lymphatic duct, all right? And this is your thoracic duct. So right lymphatic duct and thoracic duct. So these are going to be draining lymph from the body and dumping it back into the cardiovascular system prior to it going into the heart via the superior vena cava. So all this lymph is trailing all through the head and everything else back into these two openings and then back down into the heart to help you maintain your general blood osmolarity. All right, look at this beauty. Oh my gosh. So I took the initiative and I built a camera rig to hook up to this scope so that we could see histological specimens in gorgeous form. I can turn this thing on and you can see the level of what we're dealing with here. And it's a great view of this lymph node slide. So the downside of this is that it turns out is a lymph node slide, which is one I just had randomly hanging out in my office from who knows when, is about the only lymphatic slide that's present in Shelton State Community College. I'm going to go and look at a few other places to see if I can find some more, but it would appear, oh, look at this. Inguinal lymph nodes. You see them? There they are, man. Right inside of there. Those are inguinal lymph nodes. So they're giving you an idea of what you're dealing with. In fact, if nobody's around, you can dig at your legs or dig at your armpits, and you can feel these lymph nodes. So I've got one that's kind of close to the surface on my neck. It's been there my whole life, and I can feel this little bump, okay, deep in there, this little bitty lump, and that is a lymph node. Okay, they're hanging out in there sorting lymph for you. Anyway, moving on. I'm going to go and hunt in a few more places and see if there's any more lymphatic slides that are hidden away someplace. And if not, then I'm stuck showing you on the computer. So we'll see. All right, folks. So what we have here is a lymph node. All right. This is a lymph node. And it's not the most beautiful lymph node I've ever seen in my life, but it'll do. All right, this will be all right. I know that it's kind of hard to figure out what's what here, but if you pay attention, what you will notice is that there are some spots in there. Like there's kind of a dark spot. Down here is kind of a dark spot. And what these are parts of your germinal centers, okay, the germinal centers. So what would be happening is you can see in certain areas, it almost looks like, let's see if I can move this, right down in there, right there. It almost looks like there is a opening going into this lymph node. And that's exactly what this is. These are afferent, right, afferent vessels, lymphatic vessels. So lymph would be coming in through a big lymphatic vessel, going this way and in to the lymph node where it would come into contact with a germinal center that would look something like this. You got to imagine that we're looking at a 2D view, basically, of a very large, round 3D object. So we're only getting a slice of it. What we would have is, again, this afferent lymphatic vessel traveling in and hitting a germinal center, not unlike this. So these germinal centers are in what's called the medulla, all right? The medulla, no, totally backwards. You got to forgive my dyslexia sometimes. These afferent arterioles will be entering into germinal centers, which are found in the cortex. Just like your brain has a cortex on the outside, most other structures in your body have a cortex on the outside. So we've got these this germinal center hanging out in the cortex, and what this is an area where you would primarily find B lymphocytes. Okay, these are going to be germinal centers. That means places where things grow. This is going to be where B lymphocytes are really doing their thing. Okay, so they're going to be dividing, and if anything's coming in here, these B lymphocytes have the capacity to differentiate, become plasma cells, and start cranking out antibodies to mark, I'm going to turn off my other camera here, to mark cells for death. Now, as we travel in to the lymph node and we get into the medulla, the core of the lymph node, you run into areas like this here, these kind of open areas, all right? And what this is, again, consider the medulla of the lymph node. These are oftentimes called medullary cords, okay? Like little cord areas inside of here. These are medullary cords, like in there, over here. And these are going to be areas where you find primarily macrophages, okay? Now, T lymphocytes will be coming in via the bloodstream and getting into the lymphatic system and traveling in via these afferent afferent vessels. They're going to go through, these two lymphocytes go through the whole thing, and then eventually, if you kind of look, let's see if we can figure this out. Can you see how there's like something coming in that way? And this looks like something's going that way. And I pan over here, it looks like something's going that way. And then over here, it looks like something's coming that way. And over here, there's one coming this way. It looks like everything's kind of funneling towards here. Again, this is not the greatest image I've ever seen in my life, but it'll do. You got to imagine that the afferent lymphatic vessels are coming in, and then there will be an efferent vessel or two coming out down in this area here someplace. Again, this is not the view of the lymphocyte or lymph node that shows these efferent vessels, but efferent vessels all the same. Okay, so efferent vessels going this way, and then afferent vessels coming in. Afferent coming in, traveling through, and then efferent coming out. So you got to imagine, again, as these, like for instance, a bacterium or something that's gotten into your system, as a bacterium comes into the lymph node, it's got to make its way through the germinal centers that are like little nets of reticular fiber, basically, where you find a bunch of B cells, and then traveling through where all these macrophages are hanging out, checking on their major histocompatibility complexes to make sure they're self versus non-self, and if they're non-self, they're going to be destroyed. And then that's going to make its way out of the lymph node. So that's how this works, folks. That's how this works. This is a lymph node, and I think that's about all that you need to see. However, I will give you a little bit of zoom. I mean, I got the camera rig set up. I might as well use it. Let's see if we can focus a bit here. Yeah, that'll do. So you can see a nice germinal center there, parts of a germinal center, germinal centers. They're all over the place. All right, I can zoom in a little further just because we have it set up here. And apparently my camera is not quite in the right spot. It's okay. Let's just go back to here then. Yeah, that'll do. All right, so germinal center. So this is a lymph node. All right, folks, just so we have an idea of what's being dealt with here, again, I have your PDF here. You can use this to help you study. The stuff I'm going to ask you on your exam are off this PDF, but I will be telling you what I want you to know. Okay, if I don't say it on this presentation, you're not going to be seeing it on your lab test when it comes to the lymphatic system. So here we go. You need to realize that you indeed do have cervical lymph nodes. You have axillary lymph nodes, and cervical in the neck, axillary under the arms, inguinal lymph nodes around the legs. There are also lymph nodes all throughout the body and a whole variety of other places, but there are big groups of them where the legs connect, the arms connect, and where the head connects. Because you got to imagine, we're trying to keep track of things before it gets to the core of your system. Now, built into this, we also have the thymus gland, which kind of goes away as you age, so I don't worry too much about this. You're not going to be seeing a lot of details on it as we progress. I will, however, point out your spleen, which is here, and up in the jaw, you would obviously have your tonsils. And again, down in the lower portions here, in your small intestines, you'd have Peyer's patches, specifically in the ileum of the small intestines, and I'll tell you why that is as we progress. All right, so here we have a good breakdown of the lymphatic system, just a basic idea of how it all fits together. Next, this is a lymph node. Not the greatest image I could find. I wish it was a little less blurry, but we're going to make it do with what we have because this is the image that your book uses, so I figured it would be ideal for us. What I want to point out is a lot of afferent vessels leading in, okay? Very few efferent vessels leading out, so that when lymph comes in, it stagnates prior to leaving via these efferent vessels. It has to first pass through the cortex, so the outer portions of the lymph node are the cortex. I will point out that the lymph node has a nice capsule around the outside, and this capsule, I should say, invaginates inward and forms trabeculae. These are like projections that basically sheathe an area of the lymph node and cut it off. Imagine these as like roadblocks, so that as lymph comes flowing in, it's got to go through this area, it can't go around it. So this is like a solid fibrous capsule inside that forces this to become what we call a lobule. All right, not a big deal, but all the same, we have these areas where we have these follicles. Okay, and inside the follicle are germinal layers. All these little spots in there, you can see them here. These are all germinal portions, germinal centers, if you will. And these are going to be areas where you have those B lymphocytes hanging out, doing their thing, going through what I should say is clonal development. They are growing, they're dividing, they're doing their thing as B lymphocytes. Now, once lymph travels through these germinal centers to be tested, it then flows into the medulla of the lymph node, into areas that we'd call the medullary sinuses or medullary cords. The cords themselves are going to be areas with like really intense macrophage activity. So they're going to be macrophages and they're just chowing down. You can see it real clear down here, these kind of darker areas and then the open areas. So this would be in the medulla of the lymph node. And then again, T lymphocytes would be under immune surveillance. They'll be flowing in and flowing through the whole time. Okay, so there's T lymphocytes flowing through here all the time, and when they're hitting this central core, they're hanging out with macrophages that are being used as antigen presenting cells. So the lymph node is here. The lymph node has lymph flowing in, slowing down before it eventually leaves. It has to travel through these germinal centers where you find B lymphocytes, through these medullary areas where you're going to find macrophages, then eventually leaving via these efferent vessels. So that is a lymph node. And if you're wondering, I'm straight up following your text here from this PDF. Okay, so lymph nodes first. Medulla cortex hilus, which is just the end of it, where the efferent vessels are going to be coming out. And and then your afferent and efferent vessels. I'm giving you a little bit more information than that, like knowing about these follicles, for example, understanding the difference between the cortex and the medulla. I expect you to know that. That's good information for you to be able to look at a microscope slide and see. The downside of this being that we don't have microscope slides. Well, good ones, I should say. All right, next is the spleen, and the spleen is quite a simple organ from my perspective. So whenever you look at this, what I want you to notice is a sea of what's called red pulp with occasional spots that are white pulp. Okay, occasional spots that are white pulp. And the nature of this is as follows. These white pulp areas are no different than these germinal centers that you can see here in the lymph node. The white pulp is quite simplistically areas of immune function. So these are going to be areas where you have your lymphocytes hanging out doing what they do, same as here. Okay, so white pulp, lymphatic function. The red pulp is going to be invested with some macrophages, and this is going to be where you deal with red blood cells for the most part. So you know that your spleen has a role in removing old red blood cells. So here it is. We've got red pulp, which is pretty much the whole thing, and then the white pulp areas have immune function. That's going to be areas where you've got lymphocytes kind of hanging out. All right, next, these are Peyer's patches. I will appreciate you knowing that Peyer's patches are found in the ileum of the intestine. Did I not put another picture? I guess I didn't. So the ileum of the small intestine, this is going to be the lower end of the small intestine, and it's about 10 feet long. So it's about the biggest layer of the small intestine as well. So the reason these are here is very simple. You have a lot of bacteria that hang out in your large intestine. And if those bacteria start migrating up into the small intestine, that's very bad, because the small intestine is an area where you have a lot of absorption of nutrients. So because of this, the small intestine is set up for absorptive properties, and you don't want to be accidentally pulling in any bacteria, or if there are bacteria making their way into this portion, you want it to be picked up by lymphatic tissues. So you have these Peyer's patches. Again, look at the coloration. These are germinal centers. Okay, these are germinal centers. These are germinal centers. You've got these Peyer's patches in there. They're like an early warning system, if you will, to tell your immune system if something's making its way up from the large intestine. Same concept as your, oh geez, what's it called? Appendix. Same concept as the appendix. So these are just lines of defense for the body. And then last but not least, what you see here is a tonsil. And I will point out a few things here. Where did I put my PDF? Okay, we've got our tonsil here, number 4. So in this, let's see, do I have this? They've kind of asked you to go through and label things. I thought. Maybe they didn't. But all the same, I'm going to tell you about it because it's important. What I will point out is this is a tonsil. Okay, these are obviously found in the mouth. It looks something like this up here. You've got these little areas where you have deep concavities, and these deep concavities are called tonsillar crypts. Okay, the crypts are important because material gets into them, and lining the crypts are germinal centers. This is lymphatic tissue. This is going to have an immune function. So that's a tonsil lined with germinal centers. These are your tonsillar crypts. Same thing as this. Same thing as this. Same thing as that. Same thing as this. Same thing as this. Same thing as that. These are areas where you have immune functions. So if you're consuming some sort of product and it's got something not ideal for you in there, this is going to get into the tonsillar crypt and be absorbed in and dealt with by your immune system, so that you can have an early warning system that there are potential problems a-coming. Okay, so this is just yet another way, be it flowing in from the body to the lymph nodes, be it hanging out in the bloodstream in the spleen, be it coming in through the intestinal tract, or be it coming in through the mouth. We have ways of identifying potential pathogens by using the lymphatic system and the fluids that move through it. And I think that's good enough for me. So that's a good breakdown of the lymphatic system. I think that's all you really need to know. We have definitely hit the high points. This lab-based looking at it and identifying materials video is going to break down everything you need to know for your lab exam for the lymphatic system. All right, thanks guys.